So, welcome back to Archean. Last time you were building a truck to go mine gold, but I I changed my mind. It won't be a truck anymore. Because basically that's the way I always play this. I do a truck that has a mining drill on it, and a battery, a container, and it basically becomes that, but on wheels. So what we will actually do is a very small vehicle, just to go somewhere and place one of these there. So it will be independent, and we can go there, mine, uh, take the rocks, I'm still deciding if I want the rocks or the processed minerals. Um, to, so whether it will have or not a crusher there. But we go there, we mine, we get the resources, we uh, turn off the mine and come back, and we have some solar panels. Doesn't need to be many, although it would be nice to be more than this. And the solar panels recharge the battery while we are away, and I think this will work quite well. So first of all, we were building our wheels last time, and I'm going to use the regular sized wheels, not big, neither small, um, because again this will be now a smaller vehicle, so big wheels doesn't make sense. I think big wheels are more for trucks and this kind of stuff. And small wheels also are quite small. They are more like leading gears for planes. That kind of vehicle, right? So let's take these off, and like the shape of our vehicle will change a bit. But since we are still in the very beginning, it doesn't have a problem. Um, so what will we need here is just the pilot seat, a computer, as I said last time, and a battery. And I think that's it. Maybe a small container, just like we have there. And also, to find gold, we will use a R scanner coupled with a pivot. So the pivot is it will rotate around an axis, and we will place the R scanner on top of it, and basically we have a rotating R scanner. Uh, and we can then program the information from the R scanner to some kind of screen, so we can see where the ores are located at, right? So that's the pivot. Let's make the R scanner. Yep. Also the mini computer. Let's not make a full computer yet, because the mini computer is enough for our purpose, and the computer will be a bit more expensive for no reason whatsoever. To put in the mini computer, actually, let's start building before this gets too boring. So let's expand just a bit this scar. I think this is quite good lengthwise, but maybe it's too wide now. Uh, yeah, let's change how we do this. Just maybe let's look the back like this, so it has a bit of charm. And just here, maybe we have a little extension for our wheels. Just again to have a little bit of charm. No need to be like this. And back wheels also. This. Yeah, I think that's enough. I could have built like a chassis with the wheels lower, so we have more ground clearance. Maybe I will actually do that. Just maybe use these slopes and just have one block down, right? I think that will be enough clearance since we won't have a lot of weight on the vehicle, but we still need to go through mountains, rough terrain, so clearance is nice. Yeah. So this is the basic vehicle part of things. Let's put this over here, since this is for the future. So, computer, our scanner, our pivot. We will also do some dashboards today. And am I missing something? The battery. Let's use a high voltage battery, not because of the high voltage itself, but it holds more power. So I think it will give a a better range for us. Let's start building something not so ugly. Maybe let's do a bumper. This. Oops. I should also mention that I am a very bad builder, so I'm more of a technical guy, but I really like the dashboards to be something like this. And we have the dashboard in here. We can walk, and when we are sitting down, the dashboard will be in our view while we drive. So let's take this into account while we use our car. And yeah, like this. And it starts making the curve upwards. So the problem is we need a car that's tall enough for us to fit in, and that's not exactly something you do in real life. So the car will look a bit tall. Yeah, we need to fit in on foot, right? Not sitting down. Yeah, it's standing up. Sorry. So that's not a very common design for cars. And this is okay, but it's also too flat on the front. I will put some lights in here afterwards. In fact, let's put a light here. Sorry, it's not a light, it's a lamp. So yeah, 100 LEDs, it will take some time to craft. But yeah, once it's crafted, we will put it, let's put it like below the solar panels. So while the solar panel is blocking the sun, it will illuminate the opposite part. I think it will be a decent way to do it. And during the night, if I remember correctly, the solar panel won't like go upside down because the sun is below the earth. But I'm not sure actually. Yeah, the link will take some time, so let's keep building our car here. So I do this, but let's... The glass is a bit hard to see because everything is ray traced. Let's... This, maybe? Yeah. I think that will do. Then come back with the... slope. Yeah, I think that's a nice windshield. So, yeah, it's enough to see. Maybe, yeah, it's enough. I think I also want both doors, like both sides, to be open, so I can enter from both sides. And it's not because I need to enter from both sides, but because I want symmetry. And like if we have a door from one side and not from the other, then it will get quite cramped, I think. Let's build a slope maybe here. Actually, it's region for the seat. I think I'll put some cubes so we can easily enter, and then some slopes to get something that isn't always flat. Also, these bird corners, I think they fit nicely here, right? Yeah. So it connects a bit. Maybe I should have done this in the place where I'll be going, but my plan is to put some steps here. Just whatever. Our lamp's done. Our voltage, high voltage battery is done. Let's put the lamp. It's annoying me a bit that this place is darkness. Right in the middle. This maybe. And we can get a low voltage bridge. And make this a little bit nicer than just putting the cable directly. Let's connect this connect here. This, let's see. This. So, and a button. Maybe I should do this button here. Maybe use this wall here. I was actually planning on doing some stuff here. So basically, get that container put in here and block this place so the sound doesn't get out of here. And this would be our quiet place. But let's build a wall, a little wall. So my plan is to have a door like here. Here. Yes, I have. And I think it's a bit too much. think I'll have the button here. Now I'll pull the data cable from the silicon, just like we did the other episodes. You can put it inside the bin, that's quite useful. Yeah, so looks like it's working. Also, I will do a data bridge to tidy it up a bit, just like I did for the voltage. So, like here, it's quite nice that you can change items and the cable will still be in the same place where you left it. Like I'm using the data cable, the constructor tool, come back to the data cable, it is still there. Quite nice actually. Like this. Let's do this. And it's a little cross, but I think it's okay. Now when we turn it up. Not much light. Also, we have this bin here, this concrete bin, but we can raise the power a bit. Is this? No, the bin blocks everything. Let's remove this section of the bin. Yeah, the cable. Ugly, but take care of it later. Yeah, now I think this works somewhat. Yeah, this is now very good. So this. Now we have some light. Do the same with other side, just for symmetry. Nice. Yeah, so I tidied it up a bit. I probably will cut because nothing to show. But now we have some light here, and during the night we'll have also some light available. But for now, since we aren't working there, we can turn it off. Coming back here, the battery, I think the battery will be just right in the middle of the vehicle because it's quite heavy, so the center of mass is a good place to put it, I guess. And the computer can go I think it can come here. I put it a bit hidden away because as you can see it has quite a bit of data connectors and they are a bit ugly. So what I can do is get our composite blocks with a little, maybe without symmetry. Little thing like this, and it gets hidden away, but still easily matched. Actually, let's put symmetry. And on the other side, we put something else. I'm thinking of a throttle lever, so we can control how fast we are going. So, and we have to connect everything. For the computer also we need a disk drive, a HD. So we need somewhere for programs to be actually stored. It isn't like magic. Yes. I think pyramid nicely here. Doesn't make sense corner. Yeah, can change this. Put in here. So now it's on or it isn't. Yeah, it's quite a bit shaped bit here. I don't think I have anything. Maybe if I use the corner and do this, because technically it would be a corner here, inverted corner here, but this might work. Yeah, this another layer, and then compost. Corner, corner. Yogi. Sorry. Actually, this will be another inverted. I guess there is a better way to just do this, like maybe pushing one inverted corner. It will shape like this, but I think it turned out nicely. We also can paint it afterwards, but right now let's do the function part. Where's that? Oh, okay, the HTTP is here, so we actually have to click this part. If we click code, nothing happens because it doesn't have an HTTP to code into. So now we have it's HDD in the computer, and we can code, make some interesting things here. But for now, let's just put everything in place. Press the throttle lever. Today not good. Okay. And the throttle lever actually is bigger than I remembered, so let's take this off. Put it here. Yeah, I think this will do nicely. We can have some info in here, so have a decent amount of vision. I'll also block a bit of it right here, but I think this is going to go great. Let's make more compost, as you can see. Although I have 680, we also always need more. Let's plan our doors here. Maybe yeah, the length of the chair would be enough. Yep. We can't go back there, but maybe we do something open just back here. sometimes get hard to see what you are doing because you are placing a block, and if you move the camera position, it moves the uh, the shape you are making. But yeah, I think this is okay. It has some depth. I think this is going to look very good actually. Um, just coincidence. It's not on purpose. Sorry, guys. Yeah. How do we do this? Maybe we just do this. Just slope. Something like this. And there's a slope here. Maybe also slope this here. Maybe just one more block on the roof. We can also do like this, so it doesn't always be is in the same angle. This is not always a problem. Maybe with this, no. Yeah, so maybe not. Yeah. So there's slope here. Corner. Slopes. Maybe we can slope differently in this direction. Oh, it will be quite ugly. But also, this is very ugly. How does it actually look if we do this? Yeah, I don't like it. Just work way harder. Maybe just flat roof, and we do something on top of it. Actually, there will be something on top of it, our pivot and our scanner. Yeah, I think it will add nicely. It's this little car. Maybe it doesn't have to be all flat, maybe just this. And here we change how we do it. This. One more. And now we inverted corners, this, slope, yes, I wanted to slope this downwards. Let's it last. Maybe do something like this. This can work with the corners, or rather the pyramids. Yeah, I think it would look cool, but it's not. Can remove this also, maybe. Put it like this. Yeah, I think this will turn out nicely. Can put this in place. Now we have some kind of little bit of the little trick. And let's start our lines. This here is lower. Yeah, I think this is cool. I can actually put a wall here. And we put our container here. Maybe we only need to manually interact with it. So being like separated is no problem at all. Also, our yeah, this is basically off. But our item conduits could go through the wall. Let's maybe raise it a bit. How do we do it? This maybe. Oops. This bit too ugly. Yes. Yeah, I think this is okay. It's higher. Yeah, I think it has some kind of charm to it. The problem will be the power connections. We have the option for the wheels to have either high voltage or low voltage. Since I have the throttle lever, I think I will put directly high voltage into them. But for example, the computer needs low voltage. My FPS drop is the artifacts. Oh, okay. The computer is low voltage. Our pivot and our scanner are low voltage. Yeah, but I think it has some charm to it. This could be glass, but I think it will be yeah, better glass. Let's put our pivot here. I always forget which side it considers the zero angle. So let's put to the back point. And the scanner. Yeah, this is going to be fine. This is my chart. So we'll need some junctions because there is way too many cables. So first of all, the high voltage junction for our wheels. Also some low voltage junctions. Two of them. Okay. Data junctions, I don't think I need it. Yeah, I don't need it. And we need at least one or two power converters. So let's make two. What is missing? There's always wires. More wires. Let's get some water. Wires. More power converter. Let's put this here so I can see. And let's make some more glass. So let's start rigging this up. This takes quite a while in this game, but I think it's a cool process because afterwards you'll know everything about your vehicle. Since you built it, you programmed it, um, you connected the power to it, so you know which wires go everywhere. If you're doing organized fashion, right? But as you can see, I won't do it in an organized fashion. Like this. This is way ugly. Way too ugly. Like this. Yeah. So this will be the power for our pivot and our scanner. We can put the voltage junction here somewhere. Yeah, let's put it on the roof. Set. Let's have a nice place to put it. Here. And we have this. Yes. Now for the hard part. This. Yeah, not exactly beautiful, but it will work. Also, need some, at least one better bridge, because the R scanner is in a pivot, so so it will be that flexible cable. Let's just put it inside this, maybe. Yeah, so we can put the cable like tied it up a bit until it gets to the computer, which will actually be the hard part. The computer takes a lot of data cables, like each of the 4 wheels, the pivot, the R scanner, the pilot seat. We can also plug the battery into it if you want to like plot the battery. I think I will do it. And also the throttle lever, which is the easiest one. So let's start here. Here. Yeah, quite easy. Now let's draw also the main dashboard here. The corner. Like a big dashboard. And actually, the dashboard itself shouldn't be big. Let's this and boom here to here. This. And wait, this dashboard looks way too little, but we can put a big screen on it, and I think this looks nice because we can actually make the screen transparent using code. You'll see what I mean. And button wise, I don't know if we can put buttons on the screen. Yeah, we can, but also we don't exactly need to, because you can draw buttons on the screen. Sorry. And this usually look way better because you can customize them. So our dashboard, let's actually write the alias. So okay, dashboard, and the naming scheme isn't important, but I like to stay with first letter uppercase. So let's put this like here, rotten. So first letter uppercase, then joined by underlines, and our minimum will be 0 because we can reverse using the S key, and our maximum will be 1. So dashboard, let's the computer doesn't need to have an alias, but let's put it nonetheless. Nav. The battery, since I will be connecting it, let's put it. Yes, battery, I guess. And the pilot seat. Just see. Yeah. Smooth controls. Not sure what this does, but let's keep it off. On the wheels, left, back, new. We also need to revert some of them, so you can see that the arrow is forwards here, but here it will be backwards, so let's reverse. Reverse this one also. This will be the right, back, wheel. Here would be the right, front, wheel. Finally, left. Now we need to also rename this, so scanner pivot or scanner. But also, since the OR scanner is connected to a data bridge, we I never can remember whether the data bridge alias or the actual stuff alias is important, so I will also name this OR scanner. So they have the same alias, and there won't be a problem with me pushing data into the bridge and it doesn't connect to the scanner actually, or I need to know which of them I have to pass data. So I think this is it for aliases. We can actually remove this frame now. We have 4 wheels. It's doing nicely. Let's connect now the wheels. So in this high voltage junction, which maybe can go over here. Yeah, so it's a bit hidden, and I think it has some nice symmetry. So something like this. I actually want to connect to this one because this one I can do the same scheme for the power converter and then go into the computer. I think it will make more sense when I do it. Let's put it like this. So now from this we can connect the wheels. Yeah, since this is square, it's a bit more straightforward, but as you can see, it's quite hard to see. So what you are doing when you have lots of different building blocks, like I have here, right? This is a column, this is a column, this is a wall, this is another wall, and over here we have this just tiny piece, this wall. So everything has a internal wall, but when we do bigger pieces like this one, it has more space to see. So sometimes you have to keep this in mind. Your designs. So I think this is good. I don't think I can put some kind of blocking here. I can. Oh, I can. Okay. So maybe hide somewhat. Maybe not. Also, it doesn't look that bad. Well, we can always tweak it later. So I think I can connect it directly because everything's under the floor. Nothing will show up in here. Do the same for the other side. And now I have 4 wheels that are powered but not working because of the data cables. So, let's connect the data cables now. Maybe like this. What is this? Oh, it's the dashboard data. Yeah, let's pull it all the way up here. Up here. And then we can not intersect with this cable. And connect it. I think that's nice. Is it going? It's showing. Yeah, sometimes you to do things quickly and it doesn't work out, but also I probably should remove this empty space with something like this, maybe. And we can change this to match. This. Actually, as this okay. This was a slope, so we have to change this. This. Sorry, slope. Corner. And now we don't have something to put in here. I can put a slope like stylized, maybe. Old. Doesn't look good. Maybe we can. What can I do with you? Maybe start from here. So there will be a slope like this. This, yeah. It would be like this. Does it look too bad if I put this slope? Yes. I don't think so. The front's still flat, but as I was saying, but I forgot, there will be some spotlights here. It's missing for LEDs, wires. Let's make 1,000 of them already. Some diodes, LEDs, more diodes, why not? Let's wait for everything to get done. Also, we need water. Yeah, getting that wood will be very useful, so we can automate crafting. Also, pulling water and using the geothermal energy. Yeah, it will be quite an advancement. So now we are doing the spotlights. We were doing more is just yeah. This is it look bad either way. So maybe like this, then upwards. Yeah, keep under the ground until here. And something. If you hold shift, then you can place on the wire instead of in the wire. Yeah, that's a very nice tip. Why is there a that not built here? Okay. Completely forgot about it. This and where's the computer? Sometimes this gets hard to find where you are because you are inside the things you built. You usually isn't inside things you built, like in Space Engineers. Yeah, you are inside, but the things are big. But this is way too confined of a space. Let's pull here. This wall. Maybe not far actually. Like this. Nice. This is going to intersect. That's quite ugly, although it's somewhere I will never see ever again in my life. Things being ugly. I mean, I'm used to it because not only I build on ugly things, but I also look into my mirror every morning. But still, when I can avoid it, it's good. Yeah, so this, top of this, then it's not on top of it. Where is it coming from? Oh, yeah. Let's put it. This. It's great. Yeah, now all the wheels are connected to the computer, connected to the battery. Now we need to disconnect the battery, the pilot seat, and still these two others. And the two spotlights we have. Let's put them these, I think. This spacing, I think, to be good. Yep. And let's build around them. Yeah. At this point, I would love to have like half blocks place, so it has some space around it or something like that. I think this is okay-ish, I guess. I can do it like this and then paint the middle part to have some kind of different color and flatness. So let's create a new palette. Let's go with maybe like palette, and you can have like standardized colors. So I think gray good here. And we can beautify this later. Let's finish the connections, and since you saw how it's done, I will just jump forward into it. Let's place the power converter for the filter, and now the spotlights, and then the splitter start junction for it to look better, just so you can see where I put things. Let's put it along the wall. Yeah. And we have enough because it's 4, so we have 2 spotlights, 1 computer. Else does need lower voltage? Nothing, so I think we are done. Let me just plug in everything. So everything's hooked up. I also changed a bit of the front here because the spotlights were way ugly, way too ugly. Also tried to put some steps here. Well, it's a bit confusing to put it, but it also didn't work basically because of this. If I put too much to this side, then it will be on this sloped part, and if I put too much on this side, then it has the wheel. We can take off the mud guard, but I think this works fine and looks better. So it's quite cozy. It's quite cool. Also made this small container to put in here. We won't hook it up to anything, but yeah, I think this is cool. We can also expand afterwards to either a larger container or 2 small ones, but I don't think it will be needed. But everything hooked up, so now we can start coding. So first things first, if you have a background in computer engineering or computer science or something like that, then you have no problem doing this. But we can do a new program, like let's call it driving, and there is a like node programming like language, I guess, but it's quite bad, I would say. Not the language itself, but to interact with this complex system, I don't think nodes work very well. So, like for example, what's output 0? You can write something here. Oh, okay. It's just to output things. But yeah, I can't remember how to use aliases in this formats, and I'm more used to coding, so not nodes. So let's convert this. Also, we can make a file called main, just main. I think, or yeah, I think this is right. And let's actually delete this program. You will see why. So delete current file. Let's make a new file instead of a program called let's say our scanner first, or driving. It's more exciting. So now basically we have the same thing, but if you paid attention, the driving program was driving.main.exe. So each would be run. The computer would run it when it initializes, but instead we can run the main file, and we can also do something like include driving. So every program that we write here, for example, let's make a variable. I think it's var like low. I can't remember if it allows us to make. Oh yeah, yeah, it allows us to make text in the global context. So if we come here and init print hello, which is the variable that is in this file, it will print hello, right? And we can also instead put something like init print hello in here. And there's a problem because init is already doing here in main. So let's name it instead of including it actually while initializing. Let's I think it's run program, right? But let's see. No, it's not. So something nice is that we have the documentation that open a window in my browser, but we also have in-game documentation. But I think it doesn't have the function that I want. Load program. Yeah, I think this is it. Let's try. Driving. I think it doesn't. Actually, driving needs to be a program to do it like this. So let me see if I can find a better way to do it. Yeah, so it was what I was thinking, but it's a file, not a program, so the difference. And this isn't exactly what I was thinking about. Actually, let's just include the other file. And we don't need to load programs. So if you do a new program, put a name here, and then do load program and this name, it will actually kind of run the program and basically not come back to the main, and that's not what I want. It's fine. So in driving, let's make some adjustments here. So for example, let's do some kind of initial logic. Like for example, let's put we can do. Actually, let me see in the documentation how this works. Here input.0, but this is quite bad, so let's make just a loop. So I think let's put tick. So every time the computer runs the program again, this will be called. And let's get some things, like for example, it's acceleration, and it's a number. Let's start it at 0, but every tick we put that acceleration is equal to the throttle. So input number, I guess. There is a something like that. Input number, and then it's the what did I call it? Throttle lever. Sorry, here throttle, and it's the zero with value, because it only has this value, and programming starts arrays at 0, not at 1. So now we are updating this acceleration value. Let's just print it. Acceleration. Save it. Second word must be a name. Okay, so this, and it's 0.5, but if I pull the throttle lever down, it goes down. If I pull it up, it goes up. Okay. So now we have this input. Let's also take the input for the pilot seat. So let's make a var forward. Zero and var let's see. Actually we can take these inputs and not putting any variable. Yes, so let's take, or I guess we also I'm a very undecided programmer, so you have to have some patience. Let's take let's call it forward direction 0, and side direction, or I guess we can call it left or right. So if we take the input from the pilot seat, for example, for here, input, it's a number. I think it's just seat, and I have to cheat to get this port, because the seat has way too many ports. So I have the wiki on another tab here. Let's get the components, controllers, pilot seat, and so the first the port number 1, so 1 is basically up or down, sorry, backward or forward. So I can put some comments, for example, here. -1 is backwards, it's forwards, here is right, and let's put it sideways here to be a little bit more have somewhat of a pattern. So now -1 is left, 1 is right, and do the same thing here, sideways here, and with the second the port number 2 here. So I can, for example, this forward here, and actually let me print the sideways here, and when I here, If I press the A button, -1, just like the comment says, and right 1. So now we know which direction the pilot is trying to go, and we can adjust our program to respond to it, right? Let me stop printing it. So, 0 is stop. Let me see if we need some more input from the seat. Does it look like it? Maybe if we are seated, it's a good thing to know. So, seated 0 and here seated where sit. So we are seated. Okay, I don't know why it's that huge number, but well, we are seated and it shows a number, and if are not seated, it's 0, which is enough for our purpose. So yes, that's done. And so since this is a very like easy program, at least the driving part, let's do it all in the tick function, but afterwards with the OR scanner it will be more complicated, so we will divide it into different functions. I think the example here has it. No, it doesn't. But we can. Alright, like I think function. Let's do it like this. So function at drive, and now this is a function drive, which we can call in this main program. So drive. I think we need the at, right? And everything looks fine. So what are we going to do? So we have the right wheels, left wheels, front wheels, back wheels. So what first thing I want to do is define the acceleration they are going. So the acceleration here is just the input number, the gear throttle, but I think it's better if we do it like the input number of the gear throttle times the forward direction. Because if we are pressing W, so forward, it's 1, so just the throttle will comment how much we accelerate, and if we are going backwards, it's -1, so the acceleration is negative and we go backwards, right? Also, I think we can actually put a brake, so a brake condition, I would say. So let's get braking. Also create another variable, braking, and that's input number, sit, and I think it's 3. Let me check. So, no. Yeah. That's 3, and if we are braking, this is equals to 1. So we can put this to have a true or false number, I guess, or boolean. Let's me print braking just to make sure. So it's 0, and when I press space, it's 1. Perfect. and if I press Control, because the third, the part number three is about up and down control. So control goes down in this game, and space goes up. So if it's equals to 1, it's space, but if it's control, it has a number, but it's -1, so it's still 0 because of this equals condition. If you have programmed before, this is quite basic. So I have a braking, acceleration. Okay, I think we can put if braking acceleration was 0, else, sorry, too much Python code. Acceleration is, so if we print the acceleration here, so it's 0. If I push down, it goes positive, but if sorry, not down, push W, it goes forward, but if I push W and space, yeah, it goes to 0. So we can't accelerate while we are braking, which is a good thing, I guess. And let me make another function here, just to compartmentalize the code and get a more structured code. So let's also commit this a little bit more. Stuff a little bit better. Positive. Works. It's S. So it's left, which is A. That's right, which is A. Braking. 0. Can't never remember if there are two else. Yes. Perfect. Seated. I don't think I need this. Just 1R0. I think this is way better than it was just a moment ago. So we have all of these like variables, and now we need to do something with them. So let's do a accelerate wheels function with the actual acceleration we want. So let us call it. I think it needs to be said that this is a number, and let's call it speed. Why not? And here we are going to output numbers, and we can basically choose whether we have front wheel driving or back wheel driving or four wheel driving. I think we'll go with four wheel, but only the front wheel wheels turn. So output number, let's put right front wheel. I think it's the 0 part, so let's check again here. This moment. Propulsion wheels. But yeah, 0 is accelerate and 1 is steer, 2 is regen, 3 is brake, 4 is a gearbox. I have never used the gearbox. Maybe we will explore this later. But I think for now it's accelerate, steer, and regen and brake. So accelerate is 0. And let me check which order we put it. So the number we want to give to the wheel is the last one. So 0 and speed. Again, this speed is already like forward is positive, backwards is negative, because we are going to get this acceleration and basically call the function here. So accelerate means acceleration to it. And let's put all the wheels. Left back. Nice. So I think argument function. I think it's just I think it's like this. Yeah. So if I push W right now, I go forward. Okay, this is quite too much. But right now we can't turn it because we don't have an output for this. Let me close this. Windows. Oh my god, stop this. We are going to move a bit while I program the rest of it. So let's also create a function. Actually, let's put it into the accelerate wheels. Braking. Then yeah. For all wheels, but another port. It's the number 2. And it's 1. So it's right. I press space. Okay, let's check the port. Yeah, port number 2 is regen brake, but we need port number 3 for the brake. So let's try and then brake. Yeah, perfect. Maybe I could do a function to tie things up, like int wheels and port is a number, and then value is another number, and then put this in here, but with the port the value. So now we don't need to always write 4 lines of code just to say all wheels do the same thing. But we also have the liberty to the freedom to do basically individual comments to each wheel. by just not using this function. So if, for example, we use it if we use it a data junction to comment all wheels together, then when we turn it, it would turn all wheels in the same direction and that kind of stuff. But I guess that's not what I want exactly. So let's put this. Let's put an else clause here. So perfect. Now it should work the same. Or not, I guess. Okay, I think when we comment to break, it stays breaking until we tell it otherwise. So yeah, that is it. Perfect. Maybe I can like put the breaking, if it's -1, then we regen break. So let's put it or break regen. Is it wrong? Okay, so if breaking, then I think I have a somewhat idea here. We could do 2 plus breaking, because basically if breaking, it's checks if breaking is not 0, and actually it won't work, but we could do 2.5 plus half breaking. Anyway, I'll cut this out of the video. So if breaking is 1, then we comment it to break. Else if breaking was -1, then comment it to regen break it. Or I guess maybe I have to put both of them at the same time. Let's check it. Maybe it's alive or right. What's the syntax here? Well, this works, but it's way too ugly. Let's try to check what's the syntax. Documentation. Oh, it's together, as if. So let's check if the regen breaks work. They don't. Don't know if we are breaking. Let's check the battery. Yeah. Drive. So there's a constant discharge rate. And if I would control, Is it charged? No, it won't. Okay. I have no idea how the ripping brakes work. But let's break before we go into the sea. And let's just forget it for now. I can like discover how it works afterwards. So break space. Oh, uh, uh just realize it that we have this here that doesn't take the -1 as an input. Let's try again. Valid scope. It's this one here. Backwards this time. Yeah. Now the regen brakes is working. Definitely. Let's go backwards. Forwards. I don't know why it's going to the left so much. Maybe we need some more weight to stabilize it. I think it's way too top heavy. Yeah, I think it's working. It's okay. So now let's do another function here. So end out groups to be basically the same thing, but one for the front wheels, obviously. And now that we have acceleration, we can also do turning. Direction will be numbered. So commands from wheels at port number 1. Let's check. It's number 1. Perfect. So not like this. And let's put in the direction. So I think actually I need the direction. Let's see in third person what's happening. So nothing. Oh, I need to hold the function, right? Yes. Sideways direction. So this one's right, the other one not so much. Why? Is the name wrong? Let's check here. Left. Oh, stop it. Let's see. Turns now. Is it turning the right way? It is. Now we can drive actually. Let's remove this window. Make the gear ratio be here, since you have so much power in each wheel. Yeah, I think the ratio needs to be adjusted. Let's brake. So we, wow, goes up every time. My God. Yeah, maybe it needs to refine a little bit. So let's hold again, but this time instead of just using the forward direction as sorry, the gear throttle as just the forward direction, like modulation, let's use it as a gear changing. So as I said, I don't exactly know how the gear changing works. let me see if it says anything. Just wheel speed ratio. Yeah, let's just see what happens. So let's put the acceleration this, but also go into actually not output number. Let's paint all wheels. And let's put I think it's channel 4. Yeah, channel 4. So now the throttle actually shows the gears. So let's allow it to go from -1 to 1, just like the gearbox says. And let's see what happens. If I go forward, yeah, gearbox goes the opposite direction, so that's not what I want. So still has a quite big of one. I see how this helped at all. But let's see. Yeah, if we put it on both, then it's much more manageable. Also, obviously needs to change the stiffness, I guess. The suspension. Back. I think half is enough. Let's see if it's better. Yeah, much better. It's also, I see that the turning speed is way too much. So let's maybe multiply it by half, because this vehicle is way too top heavy to be turning this much. I think it's better. I don't see how we can topple this. Speed a little bit backward. So yeah, this is quite nice to drive actually. I think it's the best drive vehicle I did in Archean. So what's missing for driving functionality? There are the spotlights, but I don't think I will be programming them right now. I think I'll put either another dashboard or in this dashboard. Let me show you. It's some kind of button to turn on or turn off the flashlight. Maybe like here or here. Also maybe here. But I think for driving, this is it. We have some control. Let's take it for a ride. Okay, maybe a bit too much. It doesn't turn because the front wheels are touching the ground. Let's turn it down a notch. It's way too powerful. Maybe we can do something like do these squares, but also this is getting into a very useful input, so let's put into a variable like here 0, and then here it goes into this, and then we just use the gear. and maybe like this, we have a finer control uh, because then this will be way little acceleration. Oh, it's not exact. Let's try to put into the gear also. Gear shift, gear box. Yeah, I think it's nice, but when we turn it up, it gets much faster. Yeah, don't know. I need to tinker a little bit with this, but I think this is very nice. Yeah, on low speed it works very well. Just one last thing. Let's do that when we are seated. We just brake when we are not seated, sorry. We just brake because we don't want our vehicle to wander off without us. So I think this is a good, um, it's like protection. So if, let's see it. Then we just yeah. Then we just command all wheels to stop. Zero, and then so actually let's put it right here or not. See it. So yeah, I think this is good. If we are braking or we aren't seated, then the brake will be one. But now we lost also the regen brake. So let's maybe do another way, like this. So if we are braking or we are not seated, then we command all wheels to brake and not regen brake, because I guess the regular brakes are faster to stop the vehicle, and when we are not seated, I want the vehicle to stop fast. So let's check if it works. Let's run into our base and get out of the vehicle. Works very well, I would say. Very good protection. Let's see how the battery is doing. It's doing fine. You could put some solar panels, but I guess this vehicle is way too small for them. Maybe a later one. And we can also recharge this vehicle by just connecting to that power grid. And the sun's already in the middle of the sky. So I guess for now this is okay. This episode was long, but we built an entire vehicle, connected it all up, and programmed the driving part of it. Next time we can program the R scanner and the dashboards and so on. But right now I think this will do. So well, I have yeah, this vehicle is also quite light because of the composite blocks. Maybe next time also we paint it a little bit just to have some kind of charm to it. Yeah, it's quite like so clean I can't see myself on it. But yeah, that's it. See you next time.